I had a brief discussion with him about what was done in the last class, and let me quickly share my screen so you can probably see that as well. Just give me 1 second. Um, all right, so you should be able to see my screen now. And I remember the last what you did was you talked about the EKS Kubernetes cluster, which was a managed offering from Amazon Web Services. You talked about how to build a cluster. You talked about how to use the EKS CTL command. You used Terraform for that as well. And you got the idea of what is a master node, what is a worker node. Let's probably do a bit of a recap of that for people who are not there, or we always like a recap. So let's take that. Now, this, what I'm talking about, this is irrespective of any Kubernetes offering that you go for. Maybe you want to use EKS, which is from Amazon, or you go for GKE, which is from the Google Compute Engine or GCP, Google Cloud Platform, or you maybe go for AKS, which is Azure Kubernetes Service. Irrespective of which one you go for, either you go for a managed, right, as these all of them are managed services, or you build your own Kubernetes installation, whether you use kubeadm, which is quite popular to build your own Kubernetes environment. Maybe you use Rancher to build an on-premises data center with Kubernetes. Whatever things you do, there are a couple of things which are common across any one of these platforms. And those things are, first is a master, and second is a worker node. Now, master node is usually dedicated for running the control plane components. And this is a bit of an architecture that you already know. So this is a bit of control plane component, and there are majorly, at least minimum, you're going to get 4 different control plane components. One of them is one of the most important one, which is the Kube API server. Now, when I'm saying that you will get at least 4 of these components, it's common across any of these platforms, whether it is managed or unmanaged. The thing is, you can also get more components depending upon where you are running, right? But at least this one is always going to be there. So you would have Kube API, which is the API server. You would have etcd, which is the database where Kubernetes will store all of its cluster state. You would also get the scheduler, or as we call that, Kube scheduler, and you will also get so Kube API controller manager. This is always going to be there on your masters. And the way you build a Kubernetes cluster is you want to make sure that the masters are separate server. It could be one for a proof of concept cluster, for a dev stage cluster. It could be 3 or many for a high available environment. And you can have many worker nodes available. All of them are the worker nodes then. There are a couple of things which are also running common to master or worker, and there are 2 things which are running common. One is the Kube proxy that manages the IP tables of of the instances that you are running, the Linux machines that you are running. And second is the kubelet. Think of this as a Kubernetes agent that runs on every node, and it helps you speak to the Kubernetes master back and forth. So here would be kubelet, here also would be kubelet, here also would be kubelet, here also would be kubelet running over there. So this is a bit of an architecture from a bird's eye. What kind of servers would you have? And especially when you go for a managed service like EKS, which is what we are going to be using, the masters are actually hidden from you. You know about this because you did the installation in the last class. The masters are hidden from you in terms of the masters are already managed for you. You never care about the API server being up and running, how many replicas of this API server are running. You never care about the etcd, which is a distributed data store. It's all maintained by Amazon people for you. What you do care about is the worker node. And this is where you remember you created something called a node pool. A node pool is a collection of that generates nodes for you, and these nodes are EC2 instances. I'll show you that as well. And a node pool is something that can create multiple nodes for you. You can define your configuration in the node pool, such as what is the minimum number of nodes that I want for a worker, what is the maximum number of nodes which I want for a worker, how do you want to scale up. If in case you want to do a scale up, you can define the operating system you want for your nodes to be running, and this is where your actual customer workloads will be running. This is where, when you create your web server, you create a database server, you deploy an Nginx, you deploy Redis, it doesn't matter. This is where they would be running. Your workloads, and I will talk about workloads in a bit more detail later, but they would never be making their way on master. So if you create an app, that application would never run on the master server. We never want, or at least in the work, not in the normal ideal scenarios, we do not want to run our applications on the master servers, and there's a reason for it. We want masters to be dedicated for doing the control plane, running the control plane components. If I run all of my applications on the master, they would increase the load on my master, and I might take down my master. And that's a bad thing to have in a Kubernetes cluster. That's why the managed services will just simply say, guys, I have given you these workers. You can have them as 10, 20, 50, 100. I don't care about it. Of course, I care about the money that you're going to be giving me, but that's on you. You can have as many worker nodes as you want. There's, of course, a limit, and you can just go ahead and deploy your applications there. So this is a component, and this is the architecture of Kubernetes as a master and a worker node, and all of them are communicating with using the kubelet service, one of the most important services which usually runs as a systemd service, that you can check. This has to be running. If this service does not run on any of the nodes, that node will be shown as not ready. Because the way it works is, your API server, which is running on the master, it talks to the node which is running on the worker using this kubelet process. If this kubelet process is not running, think of this, that the API or the master has no way to communicate with your kubelet service. So it will not be able to respond back to the API server. This is a bit of a troubleshooting if in case you ever want to see why my node is not ready. One of the first things that I would do if I have to troubleshoot is to see if the kubelet service on that particular node is running or not. You log in, you do a systemctl status kubelet. So this was a bit about the control plane. This was a bit about worker nodes, and I can show you that we have a cluster here called advanced, and you can see here in my compute, because see, when you run your workloads, they are going to consume some resources, and minimum they are going to take two things. First is going to be the CPU, and second, they are always going to take the memory. They might take storage. Again, this is optional to, your application which is running, not to run your application, but the application itself might not need storage, but to run, they definitely would require some CPU and some memory. And this is what we call collectively as compute. And trust me, this is one of the biggest problems that companies are facing right now when they have to reduce the amount of compute, because the amount of compute you have will be actually converted into the money you would be giving to Amazon Web Services. So you have to be very, very careful of how to allocate your compute resources to different type of workloads. So you can see here under compute, I have got two nodes available because I created a node group. This is something you already had seen yesterday, but let's take a recap. This is the node group which has two nodes, and these are my EC2 instances. You can actually see that. So you can see here, When you create your nodes in Kubernetes in EKS, which is the worker node, because you never see your master, these nodes will be actually shown in here. And these are my two EC2 instances that are running M5 extra large, M5 extra large, which is a type of my machines that I am running here. And these are the name of my nodes, which is the private IP address and the naming convention of Amazon. Now this cluster has two nodes, and you can also access this cluster under the tab called resources. So this is something you already had seen yesterday. So if I go under cluster and click on nodes, I also see the same thing here. This is the cluster's point of view. This is what the cluster actually knows about. Now, when you work on a cluster, it would be the case that you usually would be working with many people. And guys, let's be honest here. We all are here to get a job in the market. And one of the jobs that you are targeting, or quite a few that you might be targeting, it could be a DevOps engineer. It could be for a platform engineer. It could be for a site reliability engineer, which both of these are actually my favorite. You can have a DevOps engineer, platform, SRE, whatever you do, where you are going to work with. In either one, there's one thing that would be common across every kind of job title, which is going to be Kubernetes. So you would either, if you work closely with SREs and platform teams, they are the ones who are responsible for managing. They are the ones responsible for managing Kubernetes. Usually, a DevOps engineer is responsible for managing apps running on the cluster there. And this is where, if you find yourself in the shoes of a platform or SRE, or even this is good knowledge for a DevOps engineer, you would need to manage this platform with multiple teams. Imagine this. If you go to a company tomorrow, you have an interview and you get a job, you are on there day one, and you have been tasked to create an EKS cluster, right? How do you do that? There are a couple of things that you would need to know. First, you need to know how much compute do you want. You have to do some sort of mathematics that how much compute, which translates to what kind of applications are we going to run, how much CPU and memory those applications might be using. You might not know the whole picture, but at least this is going to give you an idea that roughly I would need about 20 vCPUs, and I would need about 80 gigs of memory. Now, this one is a substantial amount that will be translated to money for Amazon, and you want to use these compute resources as efficiently as possible. And the way you do that is you create one Kubernetes cluster. Maybe I can just create a shape here with the color white. Okay, so you create this one Kubernetes cluster. On top of that, you logically separate these resources for different teams. Again, this is your Kubernetes cluster. All right, this is your Kubernetes cluster. But on top of that, you create these virtual partitions for your different teams that would be using the compute. So you can say, all right, there's team one called ADI, there's team two called Firestorm. In the company where you're working, there are different engineering teams, they're working on different products. There's also one more team which is called PageLog. I'm just giving random names at the moment. So what you do is you share the same cluster with all of these teams to maintain highest level of efficiency. Because if you were to give 20 vCPU and 80 gigs here, here, and here, it would translate to 20, 40. Eventually, you're looking at a bill for 60 vCPUs and 8, 16, 24, 240 gigabyte of RAM. And trust me, if you do this, where it happens, it depends upon how much the team is actually going to use. But to start with this, you might be shown the you might be shown the door to that company. What you should try is you should have a Kubernetes cluster which is shared amongst different teams, and you should give them the resources that they need. So maybe you do some gathering. You talk to the ADI guys and you say, how much CPU memory do you think you would be needing? And this guy says, for my application, I would probably need 5 vCPUs, and I would approximately need 20 gigs of memory, which is what we call as RAM. You go to the Firestorm team and you do the same thing. This also says we need 5 vCPUs. We need 5 vCPU, and I would also need about 30 gigs of memory. And you say, okay, that's something what we can do. We have that. And you come to the page log, and then they also say we need 5 vCPUs, which is a virtual CPU, and 3050, and you say they're going to need 20 gigabyte of storage. Now this plus this plus this is less than this. So you can serve multiple teams from the pool of compute resources that you have. But you want to do this in a secure fashion. That means if the ADI team is running their applications, it should not be affected by the Firestorm team's applications. If the Firestorm team developer is working on the cluster, they should only be able to use their application. They should only be able to see their resources. That's extremely important. And it is a term which is called multi-tenancy. Just like you live in a building, you might have your own apartment on the first floor. You can go to your apartment. You can use your apartment, but you cannot use somebody else's apartment, even though it's the same building. So you have to make these separations on the cluster. And the way we do that is we use something called namespaces. A namespace in Kubernetes is kind of like a virtual project where you can give people access on these namespaces, right? And you can then define the limit on these namespaces. That, okay, the ADI engineer would have access to the ADI namespace. The Firestorm engineer would have access on the Firestorm namespace. The page log engineer would have access to the page log. So this guy can look at his or her own project on, namespace, but if they try to look on somebody else's, that's not going to work out. You would not want somebody else looking at your namespaces when you are working in your company. There has to be a sort of separation. What if you might have stored some secure data, right? And somebody from a different team tries to maybe access this, maybe just by a mistake, because people are not that bad in a company, but still, when you're working with multi-tenancy, having this sort of isolation becomes imminent. You cannot go without having this sort of isolation. And that is done on a Kubernetes level, which is called namespaces. And you can see that here on your resources tab. When you click on namespaces under the cluster, here's where you can, or actually you can just go to your overview, go back to resources. Here you have the namespaces there. And I have got default, game 2004 new, kube node leases, kube public, kube system. I've got about 5 namespaces where I can put different applications. Now these 2 nodes that I have here, you see, these nodes are actually used amongst these 5 namespaces. So your hardware, your compute resources are still being shared by people, but they get their own reserved resources. So this one was given a percentage of the compute here, a percentage of the compute here, a percentage of the compute here. So you share your hardware with multiple teams in a way that they get what they're asking for without using somebody else's resources. And that is what's done by using the namespaces. So we can go ahead and you can actually, you can see that I've got 5 different namespaces, and then you can look on the workloads, and these workloads, which is running in a pod, we will talk about that. They are scoped to a certain. If you go to a pod, if I click on default, you see it says there are no pods available. This cluster have no pods running in the default namespace. But if I go to game 2048 new, you see I have got a couple of different pods running. So as I change my namespace, my view completely changes. I can see all of these namespaces because I am the cluster administrator. But if a new person comes on board, let's say there's a developer who wants to only or who wants to work in the game 2048 new namespace, I would create him a user. I would bind him to this namespace only. So they will not be able to see what namespaces are there on my Kubernetes cluster. They will only see their namespace and they will only see their resources that they have created. Now, we've been talking a lot about this word called workload. What does that actually even mean? See, we use Kubernetes to run containers. Actually, we do not do that. You might have heard that Kubernetes can manage your containers for you. It's completely bogus. It's completely wrong. Kubernetes does not manage your containers for you. It is the container runtime that manages those containers for you. And this container runtime is running on all the nodes, whether you have a worker or you have a master. So let's say the flow is something like this, where you have a master node, and let's say you have this worker node. You have a kubelet running over here. You come to the master and you say, I would like to create a container. I would like to run a workload. The master will speak to kubelet because it is its entry point for that node. The kubelet will actually speak to another component called the CRI, or the container runtime interface. It's called the interface. And this is the one that would actually create the containers for you. Now, this CRI, or the container runtime interface, it could be many different options. You could use Docker, which was very popular. You could use Cryo, which is one of the other container runtimes. You could also use Container D, which I think EKS is using Containerd by default. I could be wrong, but that doesn't matter. All of these, what you want is to be able to create a container, go inside the container. You might be able to see the logs of that container. All of that is being done by the container runtime interface. So what does Kubernetes does then? Kubernetes is a cluster orchestrator. It manages these container runtime interfaces. It manages these containers on a scale. Rather, it manages all of the things that are happening on this worker node at a scale. So this is where you can just come to Kubernetes and you can say, here's my image, which is my Docker image. I want five containers running for that. Figure it out. Where do you run? I don't care. Which server? I don't care. What I want is 5 containers of this image. And this is where Kubernetes masters will actually speak to the worker nodes, again using kubelet. And master says you will be running 2 containers and you will be running 3 containers, because that's the sum of what the user is asking for. So Kubernetes does not manage containers for you. Rather, the smallest fundamental unit of work in Kubernetes is called a pod. Kubernetes knows about this. It does not know about containers in the end. It knows about a pod. So you go to Kubernetes and you say, I want to create a pod from this image and give me 5 pods. You never say containers. You always say pods. And there's a reason why Kubernetes come up with the construct of a pod, because in a pod, you can create multiple containers. You can run multiple containers in a single pod. And Kubernetes then does the scheduling on this pod level. It says, okay, you want me to create a pod. Let's say this is a pod, and you want to run 2 containers inside of that. There could be many reasons why you might want to run multiple containers in a pod, but we are not going into this because it would be too much technical right now. But you give this to Kubernetes and you say, I have a pod where I want to run 2 containers. Kubernetes sees this as one single object, which is this one pod. So Kubernetes master will give this to the worker node, and then talking to kubelet, the kubelet will give this to CRI, to the container runtime interface, and it is the container runtime interface which will actually create 2 containers for you and make sure they can communicate with each other. And that's how an actual pod is going to be created. So you never say, I want 3 containers. You always use the terminology that I want a pod. Now your pod could very well have only 1 container. Many of the times your applications might just be running as a single container in a pod. So these terms are quite interchangeable. You can say, I want 5 containers of that, which technically is not true, but it translates to, I want 5 pods of that application. They are interchangeable, although they are not the same. So we always talk in the terms of a pod. Now it's also important, how do you speak to Kubernetes? It's also very important. The way we can do it now is using the UI, which is one of the ways that I can use. I can see my resources. I can click on any of the pod there. I can see the pod IP addresses. I can see that this is a very good example. This pod is running in the kube system namespace. It is running on this node because pod has to run on a node because that's where the containers are running. And within this pod, there are 2 containers. You see, there are containers, which is 2. One is named AWS node. One is named as EKS node agent. So your pod may or may not have 1 or more containers. I can try to find maybe another pod in my own namespace. If I go to that pod, you see this one is only running 1 container. So you can run 1 or more pods inside your given application, inside of your given application pod there. But you have to talk to the Kubernetes cluster. And the way I am doing is, it is diabolical. It's really stupid that I am talking to my Kubernetes cluster using the user interface, because that's not how you connect. You talk to a Kubernetes cluster. You always do that. Most of the ways that you talk to the Kubernetes cluster, you could use a UI, which not a lot of people are very fond of. You could use the API. You could also use the CLI. And this is one of the most, these 2 things are quite heavily used to talk to Kubernetes. Whichever you use, it does not matter. The component that you are talking to is running on the master node, and the component that you are speaking to is the API server. This is your entry point to that cluster. This is the one that you are talking to, that show me how many nodes I have, show me how many pods I have, go to that pod, delete this pod, create this pod. Whatever you do, all of that goes to the API server. So a pod is a collection of multiple containers, as we saw that, and multiple pods can be running on different nodes. Here you can see I have got 5 pods in my namespace, and they must be running on these 2 nodes that I have. If I click on one, this one's running on 172.31.16.10. This is on 16.10. The other one is running on 42.190. Because these pods have to, this is just a process. Think about it. A container is just a process. A process will always run on a node, and this is where they are running. And because I only have 2 nodes right now, the pods are sharing this node. Any workload that I run, which is running on these worker nodes, they will be running on this particular compute resource itself. Now, I told you that there's one way you can use either the UI or the API. The UI is not it's not very good in terms of working with Kubernetes. It doesn't allow you to do a lot of things. The API could be a bit more difficult to master because it requires some programming knowledge, and we might not have it yet. CLI is one of the very good tools, and the CLI to talk to Kubernetes is called kubectl. Kubectl, kube control, it doesn't matter. You can use that to actually see things like kubectl get nodes. So you see, it is showing you that you have got two nodes available. Nodes is a kind of resource in Kubernetes. So you can see you have got one node and two nodes. Both of them are ready state. They have been running for like 4 hours and 23 minutes. And what is the version of Kubernetes that they are running? Node is one of the options. You can also do kubectl get pods. And it tells you no resource is found in default namespace.
Hello, Shubham.
If you remember, yes, please go on.
Okay, so is it possible? I know if one start up an instance of an EC2, it's possible to pause it. So when you are running a cluster on AWS, is it possible to pause the cluster?
It's technically not possible to pause a cluster because there's no button that way, right? But what you can do is, so there's a very good answer to that. The master that is running, the masters, you cannot pause because it's something that you don't even see on the user interface. You don't see that. However, the worker nodes that you have here, the worker nodes that you have, this is where your applications would be running. If you want to really pause it, I mean, it's still not pausing it, but you can delete these worker nodes. Or you can scale down on the number of workers that you have. If it goes to 0, you're only then paying for the management plane, which is running in AWS, because you don't see that. This is not pausing the cluster, but it could be like a temporary shutdown of your application clusters, if that makes sense.
Okay, that makes sense.
All right. So what you can do is then, as I was showing you, one of the commands that you can use is kubectl get pods, and kubectl is actually, it needs to authenticate to the cluster, and you can do that using eksctl command that I might need to find it here. Where's it? Okay, I think it's not here, but maybe it was in my bash shell. There you go. So this is the command that you would need to connect your kubectl to the actual cluster you have. So you would use AWS EKS update the kube config for me. Don't use the help. Update kube config will actually give you the right file that you can then use with kubectl command, right, in the background to connect to your cluster whose name is advanced and which is running in the region EU Central 1. So this is how you would connect your kubectl to your cluster. Now you can see it says there's no resources found in the namespace. So you can actually see things in a different namespace. You can do kubectl get ns, or you can do namespace. Some resources would have a short form as well. And these are the 5 namespaces that you see. It's the same thing that you see over here. So you can see 5 namespaces. And if you want to look in a particular namespace, because by default, I am looking in the default namespace and there is no pod there. You can see there is no pod at the moment. So I can do kubectl get pods in the ---- namespace called game 2048 new. So now you see you have got 5 pods running. right? Now you've got 5 pods running. You can also do the same thing by using -n, which is a short format, to show me the pods in that particular namespace. So this is how you can use pods and namespaces together. However, so we learned how to speak to the cluster, we learned how to see the namespaces, we learned how to see the nodes. Now let's talk about how do we create an application. And when I say application, you need to see how do I run a container, which essentially is enclosed by a pod. So it turns out, how do I create a pod with your application? And there are many ways in which you can do that. You can either create the pod standalone, and you can use kubectl for that. And don't worry, I'm going to give you the cheat sheet because it will take some time to get familiar with these commands. But you can do kubectl run. That's going to create a pod for you. And one of the very beautiful things that I like with kubectl is it has the examples right there and then and there. For most of the commands, it will have an example. Right? It will have an example. So here you can see if you want to start an Nginx pod, you can just do kubectl run and the name of the pod. So here you can see kubectl run. The name of my pod could be my pod name is Nginx. It doesn't really matter. The image that I'm using is Nginx. So this is the pod I want to create. I want to run a pod from the image called Nginx. And then you can also specify the namespace that you want to run this in. I can run that in game 2004 2048 new, for example, or I can give default as well. And if I do that, it says pod whose name is my pod name is Nginx created. And you can then do kubectl get pods. It says you have a pod, you asked for one pod, you have got one pod, and it is running for last 11 seconds. You can also get more information about that pod. When you want to see more information, you can use a describe. You can do kubectl describe me the pod whose name is my pod name is Nginx. If you don't give this, it would describe every pod in that particular namespace. So I can do kubectl describe pod. My pod name is Nginx, and if I hit enter, you see it gives me a lot of information. Things that I am quite interested in is to see that this pod name is my pod name is Nginx, running on the default namespace. It is running on this node, right? When was it started? And what is the IP of that pod? And how many containers are there? It only has one container whose name is my pod name is Nginx, and it is coming from the image, which is Nginx, and there's a container that is running with this ID on that node. So if I go to the node and try to list all of my containers, I would see this particular pod. Now you can also see events which are quite interesting. See what happened. The moment I did kubectl run, the scheduler comes into the picture. You gave your request to the API server. The first thing that happens, the API server asks the scheduler, hey, can you please find a node for me to run this pod on? And this is what the default scheduler did. It assigned a node, or it assigned your pod to that particular node. Then the kubelet has been pulling the image because the node does not have the Docker image. So the image was being pulled, and it says, yes, the image has now been pulled. And that is where you create a container and you start a container. This is the event that has happened. And this will be for any type of pod that you create, irrespective on what node that you are creating it for. So as again, I can see my nodes, I can see my pods. You can also see -o wide just to see the IP address of that pod. Every pod gets an IP address and the node that this pod is running on. But this is not the way we actually create pods. See, the main reason of Kubernetes is to orchestrate. If I create a single pod, Kubernetes does not know about what to do in case that pod is deleted, right? Because it's a single, it's like it doesn't have a controller on top of that. It's just a single pod in a very wild west. So if I delete that pod, which I can very well do using kubectl, please delete me a pod whose name is my pod name is nginx. See what happens. The pod was deleted. If I try to get the pod again, there's nothing in that namespace. Kubernetes said, okay, you asked me for a standalone pod. I created that pod. You asked me to delete that pod. I don't know what to do after that. That's deleted. And this is not the way we create applications. Rather, you want a way to orchestrate your application. You want to tell Kubernetes that I want 5 replicas of this application at any time. If one gets deleted, create me another one. I don't care, but I want 5 replicas at all
Hello.
times. Yes.
Shubham.
Uh-huh.
Hello.
Yeah, I can hear you. Can you hear me? Lekan, I don't know if you can hear me. Did you have a question? Oh, I guess not. So rather than
Okay,
creating a single,
Shubham, I
yes.
have a question. All right, so I assume that, okay, fine. So you already have this infrastructure set up. So if we have an existing infrastructure on AWS, and then I want to connect to it. So anyway, there's something I said I want to raise with Dari. So we started from when you have, is it a 3-tier application something where you have your NAT gateway, you have your application load balancer, you have your Bastion, and then if you want to connect to your infrastructure, you have to connect to Bastion and the likes. So when it comes to EKS, or maybe you have your infrastructure within the Kubernetes now, which so how does the infrastructure look like? So for instance, now I'm an engineer, and then okay, let's say maybe a DevOps engineer, and then I want to set up an infrastructure using Kubernetes now. And then so how does that infrastructure, how does it look like? I mean, can we have maybe like a diagram that says, okay, fine, when a user, okay, so I have Route 53, okay, so the user coming from there, and then it's a NAT gateway. I know because I did something in the course of the week, I mean, which is Ingress or something. So I know, I mean, a NAT was created. What's it called? A load balancer was created. Though I don't understand, I mean, what was going on. But in my head, I'm just trying to say, okay, fine. Is it possible to have maybe like a picture? I mean, as you, I mean, train alongside me. So I don't know where, if that will come up. So one can have that visual of what that exact infrastructure looks like. And I mean, that is one. And then two, if there's an existing infrastructure, how do you connect to it as an engineer? For instance, you have a cluster running already, and then I've already set up my system. I have what's it called? I have kubectl running. I have is it EKS CTL running. I have what's the third one now? So I mean, which I did. So how do you now connect to an existing cluster? So do you connect through the Bastion, or I mean, you connect directly to the cluster? I don't know if you get my question.
I get your question, and I really don't
Okay.
want to be cocky about it. But a lot of things that you are asking for, my answer would be, it depends. And I would like to take the second question that you have. Say, that here's your Kubernetes cluster, right? And I'm going to take these questions in the EKS point of view because that's what we are talking and it would be helpful for other people. Let's say you are running an EKS cluster and this is Amazon. For me right now, I am not on any Bastion host. This is me at my home. This is on my own computer where I'm running the kubectl command. So either I could have, made an SSH connection to this Bastion host. And then because now I am inside AWS, I could use a kubectl command. This is one way that I can do. I can also connect from outside. And the reason why I can do it both is because my cluster endpoint, the API server, is exposed externally. I have a public endpoint that is reachable. So if I show you here in the overview, you see, this is the API server endpoint, and that is publicly reachable. So would you be able to connect to your cluster or not from a Bastion or from outside? It absolutely depends if you have a public reachable cluster or not. Does that make sense for the first question? For the second question that you had?
Yes, it makes sense, but how secure is that?
It is, again, it depends upon how do you say security, because right now, if you think that your Kubernetes cluster should only be accessed from within Amazon, you do not have to make it public. Then you have to use a Bastion host. It is, of course, when you put something over the internet, the security is always in a question compared to if it was completely local, it would be a lot more secure. But again, because Kubernetes uses TLS, it uses certificates to encrypt the traffic. I would say it is secure as long as somebody on your computer doesn't come and get what's called the kubeconfig file.
Okay.
Because reaching is one thing, but authenticating to this API server requires some credential. So kubectl uses something called a kubeconfig file on your computer to say that, hey, Kubernetes API, I am a valid user. So as long as somebody doesn't get your kubeconfig, you should be pretty safe. Does that make sense?
Yes. So how do I do that configuration?
How do you do the configuration for what
Yes.
exactly?
So for instance, okay, so let's say I have a cluster. Okay, so in my organization, so we have a cluster, that is running on AWS. And though, the purpose for me joining this course is because I actually want to work within that space. So I should be able to, inherit that infrastructure and then be able to, manage it. So, but in my head, so, though I created one that I played with, but I've been thinking, so how do I connect to that cluster? So, do I need to create maybe something like an access key? So for me to connect to AWS, and then with that, I have a direct access to, what's it called? To the cluster, or is there any, file, what's it called? Maybe like a PEM file or something that, I need to be able to connect to that cluster. So, the person that created it, I have access to it. So if, I want to give that access maybe to another person, for instance, to be able to connect using the kubectl now. So how does this person connect to an existing cluster?
Okay, that's a very valid question. And the first thing that I did to connect, because I can tell you, because the same thing would be done by any other person really. The first thing I did was I ran the AWS configure. And this is
Okay.
where you would create a user for this guy, whoever you want to give access. You would give him the access keys and the secret. This is where the access keys and the secret keys would be used,
Okay.
right? This is where the access keys and secret keys would be used. Then you would need what's called the kube config file for that particular cluster, for that user. And this is where you can use this command, AWS EKS update kube config, and then you would define the region where your cluster is running and the name of your cluster.
Okay.
This is going to actually generate a kube config file for you. And the kube config, once generated, is then used by kubectl, because in kube config, you define two things. First, is where is the API server, the address of the API server, and second, whatever is needed to authenticate, which could be, you can think of that as a username and password for authenticating to the API server. That's why I said whoever has your kubeconfig file, they would be able to they would be able to impersonate your user for Kubernetes. Does that make sense? I can
Yeah,
show this.
it
You
makes,
can take a
yeah, makes sense. Yes.
yeah. Okay, sounds good. So other question that was how Kubernetes actually looks like. It again, my answer to mostly everything is it depends where you are running. If you are running this on EKS, it looks something like this. See, every Kubernetes cluster will have masters, and in terms of EKS, you would have multiple masters because God, I hope they really do have a high availability for the masters, and then you would have a load balancer. This would be then speaking to your masters. And for me, the address of this load balancer is then given in this kubeconfig file. So my kubectl is directly talking to the load balancer, and the load balancer then is forwarding my request to the master server. I'm not talking to one master specifically because it's highly available. And then you have these worker nodes. What you do not see is, sorry, oh my bad. What you actually do not see is this bit. This is hidden from you in terms of EKS. You do see the load balancer, you do see the worker nodes because I just showed you, but this thing is managed for you. This is hidden from you. Does that make sense in terms of a picture? How does that look like?
Yes.
All right. So as I was going on, you remember we do not create a single pod. We want to have rather an orchestration. So I can say at any point I want 5 replicas. I should be able to scale up on my number of application pods that I'm running. I should be able to scale down. I should also be able to scale up and down automatically. And for that, rather than creating a pod, we create something called a deployment. So the way it works is you create the deployment, which is called the top level resource. The deployment creates an intermediate resource called a replica set, and then and let's say you define 5 pods here. It creates the replica set, and that is where the replica set is in turn responsible to make sure you have got 5 pods of that particular image with that configuration that you always wanted. So if I want to show you, I can actually do that on my tmux session. Probably you can do kubectl get all in default namespace. Now you see, in my default namespace, I only have one service. Or let me create a new namespace. Let's do it completely new. kubectl create ns demo. That is where I have my namespace. And I want to look for the demo namespace. It has nothing. It is completely empty. So what I can do is I can create a deployment which will create me a replica set. I will talk about replica set as well. And then I should get 5 pods. Or let's start with 1, so I can show you the scalability as well. Let's start with 1 pod. So here I have 1. That's what I want. So we can do kubectl create deployment or deployment. The name of my deployment is my deployment, and the image that I want to use for my deployment is docker.io nginx, and it should be created in the demo namespace. This is fairly simple. It's pure English that you are telling that, hey, kubectl, whichever cluster you are connected to right now, please create me a deployment. And then I would want to run this in a demo namespace. Hit enter. As soon as you do this, see on the left side what happens. You get one deployment. And Kubernetes says that here you have ready 1 out of 1. That means you asked for one pod, ready is 1. So you are good to go. And this is where your pod that's available. Your pod gets a random UUID, right? 1 out of 1 container now in this pod are running, and this is the replica set. So I asked for a deployment, I got a replica set, and I also got my pod. So that's what's automatically created for you, right? That's what's automatically created for you. You can also just say, show me the pods that you have. And there you can see you have got one pod only for this application. Now, should in case I want to scale up and down, that's the beauty of Kubernetes. That's the beauty of orchestration. I can say kubectl scale, please scale the deployment whose name is my deployment, which is in the demo namespace, and I want replicas for that to be 10. Now see what happens. Once you hit this command, Kubernetes will try to find, Kubernetes says, okay, you wanted, so soon as you do, see right now what's happening, Kubernetes always works on current versus the desired state. When you created the deployment, I would just rather make it here. Desired and current. So when you created this deployment, you wanted one pod. The current was 0. So Kubernetes saw that there's a difference. What you want, what you desire is not what is there. So it created one pod for you. And this is where your states are equal. This is called reconciliation. That Kubernetes saw, okay, what you wanted, you don't have it. So it moves towards making sure that these states are equal. That's called the reconciliation loop. Now what you do, you are telling, I want 10 pods, and Kubernetes says, what I have is one pod. Oh, this is not what the user wanted. So Kubernetes now tries to create 9 new pods for you. And to make sure, the way it does it, it finds the right node. You know, remember the scheduler? It uses the scheduler to find the correct nodes for your 9 pods. It then uses kubelet to pull down the image because the image is not there on those pods, and then it creates the pod, and then it starts that pod all within as soon as I hit my enter button. Now see what happens on the left side. You see container creating, now running. All of them are running, and within 1 second I could scale my application from 1 replica to 10 replicas. That is the beauty of Kubernetes. I mean, that's the least thing that Kubernetes does for you. But let's say what happens is you have one node, you have 2 worker nodes at the moment. You wanted 2 pods of one application. Kubernetes says 1 pod would be here and 1 pod would be here for high availability. It's inbuilt in that. Now, for some unfortunate situation, this pod gets deleted. Maybe the node itself is deleted. So Kubernetes says you wanted 2 pods, you have 1 because this node is down and it eventually took down the pod. So what do I do? It would automatically create 1 more pod for you here without you even blinking an eye. Otherwise, it would be you who constantly make sure you have these many numbers and you look on the number of pods to make sure what you have is exactly what you wanted. So to simulate a node failure, I'm not deleting that node, but let's just delete the pod ourselves. So you can do kubectl in the namespace demo. So you can give the -n in any place It doesn't have to be in the very end as long as you specify that. So you are saying that in the demo namespace, I want to delete a pod whose name is my deployment 6D. It's a UUID number 6D90. Oh my God, wait. Okay, so you want to say kubectl delete in the demo namespace, please delete a pod whose name is my deployment SF8GL, the very end. That's the one I want to delete. Now, as soon as I delete that, Kubernetes says, you know what? The user wanted 10 pods. The user right now has got 9 pods. I have to make a new one. And you can see that momentarily. You can see that if you do kubectl get pod, comma, deploy, you can get multiple resources together. So this is going to show you, here you can see, ready is 10 out of 10, up to date is 10, available is also 10. If we are fast enough, or if my internet is fast enough, you will see this available will go to 9, and Kubernetes will automatically make another one for you. So if I show you there, I would delete the pod and keep looking at the left side. This pod will be deleted. See what happens. I delete the pod. It says, okay, there was 9 available, but now it's back in 10. In less than a second, it's back at 10 again. And you can see that this is a new pod which is replacing the existing pod. Think of that as a node failure. Your pods are automatically running on a different node. You can also delete every pod. You can say, in this namespace, I want to delete all my pods. Now see what happens. As soon as I do this, all of my pods are going to be deleted. You see, available is 7, available is 6, available is back again, 10. All of your pods are running. It is replacing them as soon as they are deleted. So this is the beauty of an orchestrator. You never want to go beyond the minimum number of pods that you have. But what if I really want 5 pods only? Because you saw, if you delete the pod, it comes back again. What if my application does not need 10 pods? Maybe I'm wasting CPU and memory. What if I just want 5? So there you can use the scale command again. You can say, I want now 5 pods. Now 5 of them would automatically be terminated. You see, terminated, gone. And this is where you have 5 pods now. You have up to 5 and 5 pods are available. And you can do that for any number of services on top of Kubernetes. Think about this as a 3-tier architecture. So you have this front-end service, and then you have this back-end service, and then you have your database. What happens now is you have 1, 2, 3 pods which are running for front end, and then you have 5 pods running for the backend, 5 replicas, and maybe 1 database, because databases are usually in a less number. Now the problem is, see, if these are 5 pods, every pod gets its own IP address, and I can show you that. If I do kubectl get pods in my demo namespace -o wide, it shows me every pod has got an IP address. Now the problem is your front end needs to speak to the backend. But how would they know? Because these IP addresses are dynamic. You never know the IP address before they're actually created. So how do you say front end, my application is available at this IP address? Because you don't even know the IP. And that's where that's the first problem. This is called service discovery. Second, because you have 5 replicas, you might want to separate the load on 5 replicas. So this thing had to be coded in the application itself. It was the developers who were coding this application, that the application would find out how many services I have, how many IPs I have for the backend, and then will also code the load balancing logic, which was just taking their time, which was just creating the application a lot more buggy. And that problem of service discovery is that, and the load balancing internally between the application is solved by another Kubernetes resource, which is called, I think maybe I can take another one here. This is called a service resource. So every microservice that you create, they would have their own service resources before that. And this service IP, this service is nothing, but it is just an IP address which is always static. Once created, this IP address never changes. And this service knows how many pods do you have in the background. If you create one more pod, the service will register that automatically. If you delete a pod or delete two pods, the service will remove them from the pool automatically. So the benefit of using this service is all you have to do is you create that service, you tell your application that this is the IP address of the service. It never changes. No matter how many pods you create, no matter what IP addresses are given to that pod, your service IP is stable. So all your pods now need to do is connect to that service, and the service would be responsible to do the load balancing. If a new pod comes up, the service will automatically start sending traffic to that. If the pod is deleted, it will delete it from its backend. So a request would never go to that particular pod. And you can do that. You can create a service by exposing a deployment. So you can say that, okay, I have an application in my pod. In my pod, my application is running on port number 80. The front end will talk to my backend service on port number 80. So what you do is you create a service resource and you tell the service resource that if anybody comes to you, you forward them to these pods on port number 80. So you are kind of setting a load balancer internally. So you can say kubectl create deployment and the namespace is demo and the name and the deployment name is my deployment and the port number that your application is listening on is 80. Now you see the service is exposed. That means if I do kubectl get service svc or service in my namespace called demo, you see there is a service. It is listening on port number 80. It is type of cluster IP. Now, when you create the service, there are many type of services that can be created. One of the most common one is cluster IP. When you see a service of type cluster IP, it means that this IP address is the cluster IP and it can only be reachable from within the Kubernetes cluster. Nobody else from outside can reach this service, this IP address. It is only routable within. And you want to create that as cluster IP in this case because the traffic goes from here to here, not from here to here. You don't want your applications to be exposed outside if they don't expect to get traffic from outside. Because your users are going to be using the application by going to the front end. And the front end should talk to the back end. So for internal communication, cluster IP is the best because you don't want to expose the service, the backend service outside. Now, one of the good things is if you describe the service in the demo namespace, see what do you get. A service has something called endpoints. Look at these IP addresses. So it gives you one IP address and port number, second IP, third IP, and two more. But what is that? these are actually demo-oy. These are actually the IP addresses of your pods that we just created. So a service is kind of like just a proxy. It's only a proxy for the group of pods that you have. At any given time, it knows what pods do you have. If I create 5 more pods, it would say, it would have it automatically added. If I delete my pods, it would have them removed from the endpoint. So the traffic flow looks like this. Pod number A goes to the service. The service has 2 pods in the end. These pods have an IP address 10.1.1.1, let's say 10.1.1.2. These pods will be registered in the service. You just saw that here as endpoints. This is the IP address of the pods. So this service, let's say this is the front end pod, and this is the service for the back end. And you connect to that service using the cluster IP because it's only internally reachable. So your service will register these pods and you would be able to talk to them. Now, the people who are outside the cluster, they want to talk to your front end. And this is where you also have multiple front end pods. You see, just like the back end, you have multiple pods. So you can also create yourself a service which will automatically do the load balancing for these pods. And this service type would be load balancer. It will not be cluster IP because you want this particular service to be exposed to the outside world. It would be a load balancer type. So in this case, the Amazon or EKS will actually create an elastic load balancer for you that would proxy your request to the containers in the end. So these are the more common type of services. One is the cluster IP. The other one is the load balancer. Right? One is the cluster IP and the other one is going to be the load balancer.
Ella?
So guys, any questions, comments, queries?
I have a question, please.
Please go on.
Okay, so when we have the what's it called, the service, and then it's either a cluster or a load balancer. So when AWS create the load balancer, is it like a typical AWS load balancer, or it's created within the pod? And then, in AWS, I mean, you have to pay for load balancer. So now when it comes here, so is it created on the pod, and so you're just paying for compute, like, I mean, for compute, or how does that work?
So when you are creating the cluster on EKS and you create a service of type load balancer, it actually creates you an elastic load balancer, and that will cost you money. So let's say you had 10 applications you want to expose. Each application would have had its load balancer. So you would have 10 load balancers, which I can actually show you right here. You can do kubectl get service in demo namespace. You see, it's type of cluster IP, but you can modify that to be of type load balancer. And you can do that using kubectl edit service in the namespace demo, and service name is my deployment. And here, this is the manifest. This is the YAML. Everything in Kubernetes can be done by modifying YAML. So you have to be very good at YAML. So you go in the end and you see the type here is cluster IP. If you want to change that, in case you ever decide to expose it to outside, you can do load balancer. And you save it and quit it. Now what happens, you see, so you see what happened now. Before, when it was external IP, before it was cluster IP, there was no external IP because there was no need for an external IP because you did not wish to expose it. But now, as soon as you set that as a load balancer, you see here pending. That means EKS in the background is actually creating you a load balancer. And this is the load balancer domain that has been created for you. In the background, what has happened, if you go to EC2, if you go to load balancers, you see there is a new load balancer which is automatically created for you, AC36C44. Here you see AC36C44. It's the same load balancer. So indeed, it is an actual load balancer which you would be paying for. Right now, it is not reachable because it takes some time for the load balancer to be active and ready to serve the requests. But does that answer your question?
Yes.
All right. So you see this load balancer right now is actually provisioning. Once it's done, we would be able to access our front end application on this domain. Now, of course, this would be expensive. What if you have 10 services you want to expose? Each service will have its own load balancer. And and every load balancer is going to have a domain. It's going to have a domain name, or I would easily a URL. How many URLs am I supposed to remember? How many? And that is where ingress comes into the picture.
Okay, a quick question, please. Okay, so you
Yes, sir.
mentioned something. Okay, so I can have a single cluster, and then I have multiple. What's it called? Okay, talked about name. I mean, multiple. Let's say projects now, having multiple namespace. So, how does that work here? So, if I'm creating, okay, let's assume I'm creating a cluster, for instance. So, will I be creating cluster for each of the namespace? And then if it is ingress, will ingress be creating multiple? What's it called load balancer? I don't know if it makes
No, no,
sense.
no.
So
It doesn't happen that way. So the way it works is you have an EKS cluster, one single cluster. There you can create multiple namespaces on the same cluster. All right. You can create multiple namespaces. Then you decide to create a service because service is local to a namespace. When you create the service of type load balancer on Amazon, one elastic load balancer will be created for this service, which is of type load balancer. Then if you create one more service here, which is of type cluster IP, this would need no load balancer because it is not exposed outside. So for every service that you have, which is of type load balancer, when you create that on EKS, it would result into an in its own load balancer. And here you see my load balancer is now ready to serve the request. It is going to then proxy my request to all 5 pods which the service knows about. Does that make sense?
yes.
Okay, sounds good. So here's an example of, to solve that problem that we don't want to spend so much money, you can use ingress, where ingress gives you a fixed domain or an IP address where you can expose multiple services. Rather than having one service with its own load balancer, you can use a fixed domain or an IP address, and you can expose multiple services on that particular domain. And that is called an ingress. So when you go there, you can see you have a load balancer, and it could be pretty expensive, pretty quick. So you have to be careful on what services do you want to expose to the outside world. Now, one of the other important things that Kubernetes also needs are your workloads. See, we talked about network, we talked about compute, we talked about these two things. But one thing that's also important is storage. Because what happens When you have a node and the pod, if the pod is writing some data into a folder called slash data, if that pod is deleted, sure, Kubernetes can run this pod on a different node here. But any data that you had written, it will not be available. This is always one of the very important things when you go with Kubernetes. The pods are supposed to die. The pods are supposed to be killed and recreated on a different cluster. And by default, the pods are ephemeral. That means they have no persistent storage. They have no persistent volumes available. So if you are writing some data and your data, your pod is deleted for whatever reason, maybe the node itself has rebooted or crashed, your pod will start on another node, as we just saw as a replacement, but it will not have that data. So to solve that problem, we use something called Kubernetes volumes. Kubernetes has a concept of volume. More primarily, it exposes two resources. One is called a persistent volume claim, and the other one is called a persistent volume. This is probably going to be the last thing for today, so we are not going to cover anything apart from that. I don't want your brains to to go out. I would give you a cheat sheet where you can easily see that. But let's see what happens with PVCs, or they are also known as PVC and PV in a short form. Now what happens is, let's say you have a pod that is running a database. Now Kubernetes does not know if the application that you are trying to create, would that require a storage or not. It by default starts with no storage because it doesn't know if you need some storage or not. If you need some storage, you can request for that storage, and you have to give a couple of options. First, you give the size of the storage that you want. Maybe my application requires 50 gigabytes of storage. You would get that. Second thing, you can say in what access mode do I want that storage? Do I want that as read only? Do I want that as read write many? Or read only once, read write many, or read write once? These different access modes will define how would you use your storage. Sometimes one single storage can be used by multiple nodes. For example, NFS. You can attach the same NFS directory, or in terms of Amazon, the EFS file system. This could be attached to multiple nodes at one time. So for using EFS type of storage, it would be read write many. Maybe sometimes it's not read only once, but it's only read only many. That being said, sometimes you want your application to use a storage, but only in a read only mode. Sometimes you don't want your pod to share that storage with anyone else. This is a very classic example in case of databases, where if you create one pod, it should have its own dedicated storage. When you increase the replicas of that pod, it should have its another dedicated storage. So think of this as read write once, that only once the storage could be added to a pod. So every pod gets its own storage. But in case of read write many, think of this You have one volume, one storage that can be accessed by multiple pods at one time in read, write, many. So actively, this pod can write data to this volume, and this pod can also write data to this volume. Of course, you have to make sure they don't try to write in the same file on the same line at the same time. You have to do the consistency yourself. But this is the different type of access volumes that you can ask. So you can request for a storage, and that request is something called a persistent volume claim. A PVC is a request for storage where you define the size and you define the access modes. Then Kubernetes uses a concept called storage classes. See, Kubernetes does not know when would you create an application. You come today morning, maybe in the afternoon, maybe in the evening. It doesn't know about it. So creating storage beforehand would be expensive. So Kubernetes says when you create a persistent volume claim, I have a software running on top of Kubernetes, which is called a storage class. This storage class knows on Amazon which type of EBS volumes to use. So when you create a persistent volume claim with the size and the access mode, you can also define the storage class that you want to use. Now, when you define this storage class in your persistent volume claim, which is a request, Kubernetes sees, okay, you want to use the storage class EBS. There is a storage class whose name is EBS. I will create a actual EBS volume for you. And then this EBS volume is what's actually pointed by the persistent volume. So while the persistent volume claim is actually the request for storage, persistent volume is pointing to the actual storage that your applications can then access and use. So once this EBS volume then is created, you would create your pod, or you would create your deployment to access this storage, to mount this storage in your pod at the /data directory. So let's try to create a persistent volume and a persistent volume claim. I don't remember that exactly, but I definitely know that I have got a storage class, which you can see here, that is called GP2.
Hi,
Right?
Shubham.
Yes, please go on.
All right. Thank you so much. The training so far has been so intense. So I'm just still trying to follow up and put some things together in my head. But however, there's this particular place where you were probably showing us cluster IP, and then
Mhm.
after all, we jump onto load balancer. So, and then what I noticed was that the load balancer and the cluster IP actually maintain the same IP addresses, which I feel a bit confused because I was probably bringing on-premise interaction into Kubernetes. I want to know, are they two different entity or are they the same entity? And then if they are, is this a best practice in a production environment? Is my
Uh,
question clear?
yeah, I think I can answer that. I think I got your question. If you see here, if I do kubectl get service in my demo namespace, you see the service type is actually load balancer. It was cluster IP before, but right now it is load balancer, but it still has the same cluster IP. So when you create a service of type cluster IP, let's put it this way, when you create a service of type cluster IP, it gets an IP that's only internally routable. And this is for the applications inside the cluster. And it has no load balancer attached to it because you created the service of type cluster IP. You said to Kubernetes, I do not wish this application to be exposed outside. Internally, my application should be able to talk. So if somebody wants to talk, they would use the cluster IP internal to the cluster. But from outside, they cannot. Because if you see this, I cannot ping this IP address. From outside, I cannot do that. But internally, my applications can use this IP to talk to each other. That is the way cluster IP is defined. Cluster IP is only used for applications to talk to each other, not humans from outside of the cluster. But if I create a type of load balancer, I get the load balancer, which is here. This has an external IP address, which I can probably show you. So you can see here, this is the IP address for my service of type load balancer, which essentially is a DNS name, right? So it got an externally reachable IP address, but it also has an internal IP as it was before. So additionally, with load balancer type of service, you get a load balancer and you keep retaining the cluster IP. You use the load balancer for people who are outside your cluster, but you still use the cluster IP to talk internally. Does that answer your question? Does it make sense?
Yeah, very well, very well.
All right, sounds good. Perfect. All right, so as you can see here, we wanted to create a persistent volume claim. Let's go back to this. I want to request for some storage. And I don't know how to do that. So I would go to the documentation like anyone else would do. So let's go for persistent volume claim examples. And you go to kubernetes.io. This is one of the most useful pages if you ever want to create a persistent volume, because it gives you the entire YAML. And let me open that for you. pvc.yaml. You see, as I was telling you, you define a couple of things. The first thing you define, it is a persistent volume. Sorry, I should be creating a persistent volume claim. That's my claim. So as you can see here, this is, look at line number 2. This is how you can talk to Kubernetes. You can write your manifest in YAML format as long as it is a valid YAML. In this case, you are creating a resource of kind persistent volume claim, which has some metadata whose name is task PV claim. I would change that to my PVC. And then you have the specification that I want a storage from the storage class name GP2 new. That's my storage class name. I want that in read write once. That is my access mode. And I want at least 3 GB of storage. So you are declaring what you want. You never told Kubernetes how to get that storage. You just said, give me that. Now, if you see, we have got 2 storage classes. There was GP2 and GP2-new that I just created right now. And you have to match that name. If I would have given any spelling mistake here, maybe GP2-NE, it will say there's no storage class with name NE. I can't create it for you. So you have to make sure that you give the right storage class name. What happens with this storage class, as soon as, say I can show you that as well. Maybe we use tmux. Right now, I have no persistent volumes. I have no persistent volume, which means I don't actually have any active storage. But when I request for that, when I request for this storage saying, I want to create a resource from this file. So this is also how you can create resources. You can create resources from the command line, but sometimes you might not have an option to create the resource from the CLI. So you have to use a YAML. So you are saying that, hey, kubectl, create me anything which is written in this file. And what is written in this file is the persistent volume claim. Now, as soon as I do this, if everything is correct, see what happens. On the right side, I should be getting a persistent volume if everything was done correctly. It doesn't appear, so maybe I might have done something wrong. Let's check that. I can do kubectl get. Oh, first of all, I requested this in a wrong namespace. I had to do this in the namespace where my application was. By default, I did not give the namespace, so it went into the default namespace, but my application was in the demo namespace. So I would delete that, saying whatever is in this file, please delete this for me, and I would edit to have namespace as demo. Now it will be created in the right namespace. Let's do kubectl create -f pvc.yaml. And now, right now, I don't have any volumes on the right side. Let's do kubectl get pvc in the namespace called demo. It is pending at the moment. Right now it says pending. I can describe that persistent volume claim to see why it is pending. Okay. So what would have happened, let me show you that first so I can do the troubleshooting later. What actually happens when you create a persistent volume claim where you have defined a storage class name. Once you have defined the storage class name, Kubernetes will talk to that storage class to create you a volume dynamically. Storage classes are used for dynamic volume creation. So whenever you request for it, you get that storage. This is used for dynamic provisioning. If this piece of software is not running fine, then you would have to create the volume, and then you would have to create the PVC, and you have to create this volume manually somehow. So we don't want to do this. That's why we use a storage class that automatically creates volumes for us. There may be something wrong because I created a new storage class, but let's do one thing. I would use the same storage class that Kubernetes came with, which is GP2. I created GP2-new. Maybe I would just keep GP2 because I don't want to go into all troubleshooting and you guys would not learn anything at the moment. But let's just keep using the standard storage class that Kubernetes or EKS came with. Let's do a kubectl-f pvc create. If everything should be fine, pvc in my demo namespace, that's still pending. Let's describe the persistent volume claim. Waiting for first consumer to be created before binding. That's exactly what I was kind of afraid of. So what's happening? Kubernetes says, you know what? You asked for a storage. My storage class worked. I have reserved a volume for you, but I haven't just created it yet. When you want to use this volume in an application, that's when I would create it for you. So that if you create it now and you take maybe 1 hour before you create the application that uses this, you would be paying for 1 hour more extra. So there is a type of storage class that can hold the creation of your volume, and that's why it's saying waiting for first consumer to be created before binding. So the consumer of your volume is the application itself. The consumer of the volume is the application. So maybe try that now. The way we consume this application is again given in the documentation itself here, which is creating this particular pod. And I will show you that. I would show you that how to use that. Let's say pod, my PVC name was my PVC, and let's do pod.yaml. Now we would do namespace as demo. Now see what's happening. This is the pod manifest. This is what you're telling. So you tell that Kubernetes, I want to create a pod whose name is task PV pod in the namespace demo, and you define a volume. This is the name of your persistent. So the name of the volume that you want to call is my volume, and this volume is coming from a persistent volume claim whose name is my PVC. This is the one that you created before. So as you can see, I'm telling that my pod would need a volume on line number 7. My pod would need a volume whose name would be my volume, and that volume would essentially be coming from this persistent volume claim that you just had created in the previous file, and it was my PVC. Now you create a container. See, you are telling to create a volume, but where would your application use that volume? Your pod has to, your container has to use it somewhere. When you do docker run -v/data:/data, you mean that the volume should be used at /data. So you have to mount it somewhere, and this is what's done in the containers. So you are then telling, I want to create a container whose name is task PV container from this image that has these port numbers, and it is mounting the volume. The volume is mounted at the USR share Nginx HTML, and the volume that I want to mount is my volume. It matches the same name on the line number 7. Again, I know it might be a lot more, but you would get used to it. You just need to know about these things. I would go for that again. You're creating a pod of name task PV pod. This pod has a volume whose name is my volume. It is coming from a persistent volume claim called my PVC. Then you define the containers in that pod. As I said, it could be multiple containers, but we only have one whose name is task PV container. It's coming from the Nginx image. It is mounting that volume whose name is my volume. It's the same volume that you defined up earlier. So here's the definition. Here's where you're using that volume to mount it at this location. All right. So if everything goes well, I would be able to create that pod, and I would get maybe some persistent volumes. Wait. This pod is going to be in a pending state. Now, there's something I really like this is happening because it gives me time to tell you what things can go wrong as well, not just a shiny little demo, because that's what's going to happen with you. You see, my pod is pending at the moment. What's happening behind the scenes is, let's say, if you have a pod that requests a volume using the PVC, and there is no volume right now that's being created. So the pod would be in a forever pending state. The pod cannot be created if it is asking for a volume and the volume is not available there. For whatever reason it is that the volume is no longer available. In my case, my storage class is behaving a bit differently. Expected was to create that volume, then use that volume in my pod, and everything was supposed to be okay. Right now, the volume could not have been created. I don't know why. I would have to do some troubleshooting. Maybe when we come in the next class, I can show you the demo because I would have done it by now. But essentially, you would have had a pod which was running with that volume. If you want to see why a pod is pending, because it could be a lot of reasons, you can just do a kubectl describe of the pod in this namespace demo task pv pod, and it will tell you. It should have a reference to it in the same name. It has no events. That's weird. It usually would tell you that the pod is asking for a volume that is not available. You can see here, this pod has one container. It is asking for a volume whose type is a persistent volume claim, whose name is my PVC. Get PVC in demo. Is it my PVC? Yeah, that's why, because my PVC is in a pending state right now. I need to check what's happening. Maybe I would do that after the class later, but I promise you would see a demo of that in the next class. Things can go wrong. It did go wrong, but that's okay. We got the concept. The demo is not a big thing. So gents, this is what I was planning for us today. If you have any questions, and the reason why I'm not going for the troubleshooting is you would just be sitting in the call without knowing what am I doing, and that makes no sense at all. We will do the troubleshooting when we get there. So guys, before we go and we do a poll for the next class, we are done for the class for today. Do you have any question, comments, queries? We can now take that. If not, I guess whatever I had planned, we are done, and we would start in the next class then. But do you have any questions? Anyone?
Hi,
Shubham.
Shubham. Yeah, I have a
I
question.
see many people have questions. All right, let's take it as one at a time, guys. Frank, you can go ahead, please.
All right, hi, Shubham. Yeah, I noticed there was one component on the worker node you didn't talk about. That was Q proxy. Yeah, but I understand that the service you created, which I don't know, um is it mandatory you create them manually? Because I
This
mean, when you create a namespace and you deploy you create your pods in the namespace, I is it not possible for Amazon itself, that's AWS, since EKS is managed by them, is it not possible for them to create for a service to be created automatically? I mean, the service having the cluster IP of the pods that are in the namespace. Does it have to be created manually, or do you need, let me say, an extra service to make it serverless? I mean, all this just to reduce the overhead of managing the infrastructure itself. Do you need to add an extra service to EKS, say Fargate, or I don't know, something like that, that can create these services automatically without we having to manually create them? I don't know if my question is quite clear.
it actually is. Please just give me one moment. Let's say what you can do is, I wanted to show you something.
Okay.
Just give me 1 second, right?
All right.
All right. So you see here, this is an example of my, I will delete the deployment in my another namespace. So when you say that if I'm creating an application on Kubernetes, why doesn't it automatically create a service for me? That's the question, right? Because it's all about
Yes,
automation.
yes.
So first thing is Amazon, this is something called a shared responsibility. Amazon says, I will take care of your nodes, whether they are master, whether they are worker. I would take care of them in terms of compute, that you always get what you're asking for. You always get the networking. You always get the power. They are always up and running. But what happens on those nodes is on you. Because let's say if you deploy an application of Apache web server, because the thing is, you can use EKS to deploy any sort of application. It could be a web server. It could be a database server. It could be a media streaming server. It could be any custom application that you create, and Kubernetes does not know what do you want to do with this application. Do you want to expose it outside or not? It doesn't know about that. Do you even want to expose it with a cluster IP or not? It doesn't know what kind of application, it doesn't know what kind of technical stack you have. That's why it doesn't automatically create it for you. Is that thing clear?
Yes. Okay.
Now the question is, what if I want to make that automatically? I mean, I can say, sure, Kubernetes, I want to create it. So I want to create the deployment, as well as after that, I want to have the service as well, so that I don't have to create that manually. That is where you can create something called an application manifest. So first thing, you define your deployment here, as you can see, and then you define your service in the same file, separated by a 3 hyphen, right? You create a deployment in YAML, you then give the service, and then this file could be given to Kubernetes itself. So what you just have done is you have got one file, app.yaml, and you create a deployment in that file, and you separate the YAML, and then you have a service. You give this to the API server, it will create your deployment as well as a service without you running any commands whatsoever. So if you do this, you can see, if I do kubectl-f temp app.yaml create, you will see this. So it says a deployment was created and automatically a service was also created for you. And this service called myDeploy knows about your pod. If you do a describe of the service in namespace another, you see, it knows about, the pod is not running at the moment. And there you go. The pod was having an image pull back off. This is a good thing. That means you could not have downloaded the image from Docker Hub. For whatever reason it was, Docker has a limit, so you could not download the image. But if you were to able to do that, if the pod was running, the pod would have gotten the IP address and you would have seen this in the endpoints. And that is completely automatic. And you can then also do a delete. So it will delete everything that is there in the file, which is the deployment as well as the service. So in this case, kind of like, sorry, this is the problem. I gave image as docker.io, but I should have done nginx:/latest. My bad. I've had a long day. So if I do that now again, kubectl-f create. Now, if you do kubectl get pods or get all in my another service, you would see there's the pod which is running, there's the service that has been created, and if you describe that service, it automatically registered that pod for you. And this exact thing that I just showed you is what we are going to talk about a lot more in GitOps as well, this is the same thing we do via Argo CD. But I hope you got the answer to why does it not automatically create it for you and how can you do that if you want. Does that make sense?
Yes, makes a lot of sense. Thanks.
No problem. Now there was someone else who wanted to ask another question.
Yeah, hi, Shubham.
Hi, Jamin, please ask a question.
All right, so if let's say, for example, I deployed a new app, created a service, put everything in my deployment file, and I apply it to Kubernetes, and maybe somewhere down the line, I have no use for that deployment anymore. What should I delete that will basically take everything out, including the pod, the ingress, the namespace? Should I delete the deployment or the service?
That's a very good question. And I think the answer to that, it depends. Let me tell you what I mean by that. Let's say this is a namespace that you have, okay? Now, technically, a namespace will have multiple microservices. And when I say microservices, think of one microservice is corresponding to one deployment. So I have got one deployment, which is for my notification service. This creates me a replica set, and I have got a pod. Then I have another service which stores the user's history. This has its own, because they're individual. This has its own replica set. It then has its own pod. You get the point. Then you have, maybe let's say just one more. You have a suggestion service. The suggestion service also has its own. Think of Netflix. The things that you have seen, it analyzes that and gives you suggestions as notifications that you like horror. We have a new show with horror genre, and you might like that. Yada yada yada. So here you also have a pod. Now, of course, you would have multiple pods running. Same goes for the history service, because you want high availability. And here's where. Now you create service for each one of them. This service for these kinds of pods, then one more service for this, so that you can easily do inter-application communication. Now see what happens. When a user watches a show, in this case, it gets recorded in the history. Now the suggestion service, the application is running here. The suggestion service talks to the history service, it talks to the service and then gets forwarded to the pod to get the history of the user. It generates some output, and then it talks to the notification service, which essentially is talking to the notification service in Kubernetes resource, and then gets forwarded to the pod, and this pod then sends an alert on our mobile. This is how very, very high example Netflix works, right? Now, if in case you were to delete the namespace, you would lose everything. Where maybe you just wanted to delete the suggestion service. Let's say you don't like the suggestion service, you want to get rid of that. For you to get rid of the suggestion service, you got to delete the deployment, the replica set, the pod, the service, maybe the ingress that was created. All of this has to go away to clear up the namespace with any remnants of the suggestion service. So to delete multiple resources of different type in this case being a deployment, a replica set, a pod, these things can automatically be deleted if you just delete the deployment. Because if you remember, from the deployment, you create the replica set, from that you create the pod. So if you delete the deployment, this is gone, and this is gone. But you also want to delete the service and the ingress. So you can actually use labels there. You can use labels. Every resource in Kubernetes has a label. If I describe the service, you see here, the service has a label called app equal to my deploy. The deployment will also have a label, which you can see here, app equals to my deploy. And you can select all of the resources which have that label. So just like, in SQL, you could do delete from my table where app name is equals to nginx. Just like you do that, you could do the same with Kubernetes. You can say kubectl delete me the deployment, delete me, because deployment will take care of the replica set and the pod. So delete me the deployment, service, ingress, PVC, whatever, which has the label of app equals to my deploy. Anything in this namespace that has that label would then be deleted. Of course, you have to be careful. You don't want to delete things that should not have been deleted. But this is an example of deleting everything in one go. Make sure they have the label there.
Okay, but if I delete just the namespace, will it achieve the same goal?
You will delete this deployment service and everything, but you would also lose the history service and the notification. A namespace being deleted will delete everything. Everything. So if you wanted to delete everything, sure, go ahead. Delete the namespace. But you would lose your notify service and you would be probably a lot more popular in your company for a lot less, lot bad reasons if you do that. You know, you wanted to get rid of one service, but you took off the whole namespace. And that could be wrong. That could be very bad.
Okay, thank you for confirming. Because I'd faced an issue, I think 2 weeks ago, where let's say, for example, there's a particular deployment running that's called my app. Ingress, my app, namespace, my app, everything, my app, right? And for some reason, whenever a new build is pushed from GitLab, which is supposed to run the pipeline and deploy into Kubernetes, right? The developers couldn't see the latest changes, which was weird. But from checking the image build tag and what we have currently running on Kubernetes, they matched. So we assumed there was some form of cache somewhere else, maybe redirecting them somewhere else. So we said, okay, let's append something to the ingress and probably the namespace. So what I did was changing my app to my app v2 for the namespace, the ingress, everything that regards that particular deployment. And I applied that and it worked fine. Everybody was happy. So it was time for me to delete the previous. So no, not delete. So after a year, we confirmed that, oh, okay, this was a problem, right? It was probably a caching system somewhere, right? I noticed that my app, the regular my app, was still running, which was weird after I had done the updates from regular my app to V2. So I thought, okay, let me delete this, and try to recreate that deployment to see if that fixes the issue. But whenever I tried deleting my app deployment, deleted the namespace, deleted the deployment, the service, practically deleted everything, it kept on recreating for some reason. So I was shocked because I knew that, if you delete the namespace, everything goes. But even when I deleted the namespace, it kept on coming back. So how I was able to resolve that was just to create a dummy deployment that had my app name, apply that on Kubernetes. While that came up, I now had to delete that entirely before the entire my app deployment went away. So I was surprised why the first version, that was my app, kept on regenerating even after I deleted the namespace, deployment, and even services, but it just kept on coming back for some reason, which was weird for some reason.
Were you using, okay, let me ask this question. Were you using Argo CD somewhere in this whole setup?
Okay, so where Argo CD come into play was, so we use Argo CD as our kind of Kubernetes monitoring, right? So when I did this change from regular my app to my app v2, right? I just went into the Argo CD Kubernetes manifest file and just changed the YAML file there from my app and appended v2 to everything and applied it, and it worked. I checked Argo CD, okay, fine. The new stuff was created. I tried deleting the old one from Argo CD. You delete, you refresh, it comes back. I said, okay, maybe it could be something else. So I went via terminal, deleted the everything, but it kept on coming back and coming back for some reason. So after I created the dummy, which had the old name, so when that spun up, checked Argo CD saying, okay, something now is mapped to that namespace and deployment. I deleted the old one from Argo CD and it didn't come back.
See, I'll tell you what was probably happening there. You might want to take a look at this. And this is important for everyone else. See, you are using GitHub, where you have the namespace. That's where you have the deployment and everything. That is being sourced by Argo CD. And that's then being applied on your cluster. If you delete the namespace, Argo CD says, GitHub is telling me to create a namespace. There is no namespace right now. I would create that back. And I would create all the applications inside of it. This explains why your namespace kept coming back when you were deleting it from the command line or even from the Argo CD. Because essentially in GitOps, you have to remove that in GitHub. In GitOps, GitHub is your source of truth. So what's happening, Argo CD keeps refreshing its manifest, so it gets the latest copy from GitHub, and it keeps, and you might have auto sync enabled. So anything that changed here, Argo CD says, this is not what I wanted. So it will automatically sync you to the changes that you have in your file here. So this is where you need to remove the namespace if in case you really want to get rid of that. I would assume, which probably is what's happening.
Hello, Shubham. Good afternoon.
Hello, good afternoon.
Good afternoon. I think you just hit the nail on the head. That's what is happening. They are using a well architected framework approach in the environment, and that involves using IAC and repeatable, just for them to have repeatable deployment. So in that they have the entire pipeline built from whichever repo they are using, whether GitHub or Bitbucket or whatever. So that's what is just like using Ansible with your container on Azure. Thank you.
All right. I think that I could see when you said things kept coming back up, I was like, okay, that maybe Argo CD somewhere is involved. And what you are doing, deleting the namespace, guys, this is something called an anti-pattern, especially when you are using GitOps. If you are using GitOps, you are not really supposed to make changes on your cluster because they would be removed if you have autosync enabled. That is why we say any changes you want to do on the cluster, do it on GitHub. Never do it live on the cluster. You can do a kubectl for troubleshooting things, but you see, you would bite yourself in the ass if you keep doing that. So do not do the anti-patterns. Don't be that guy. Please, GitOps properly. That's the answer.
All right, thanks.
No worries. Okay, I think that's pretty much all the questions, guys. We have already been half an hour extra. Oh man, you guys are really enjoying it, aren't you? All right. So I think we would have a poll on Slack when the classes should be. I hope we can agree on a certain time. So I would see you next class, whenever it is, whatever we decide.